In this session, I would like to talk about how to solve recurrence relations. You know how to write recurrence relation so far, right? So there are a lot of different models of recurrence relations, and some of the recurrence relations are very difficult to solve, and some of the recurrence relations doesn't have solutions. There are three models I can say. So recurrence relations, some are easy. For them there are easy procedures. If you apply the formula, you can get the result. There are some recurrence relations which are solvable, but they need some tricks, and the trick depends on particular recurrence relation. Okay, so using some tricks we can compute some of the recurrence relations. There is a third model. In the third model you don't have solution, nobody knows how to solve it. Okay, so we are going to cover the only case number one, and we are not covering second case, third case, and especially, so we don't require for them, we don't require them for gate. That's why the tricks, applying tricks, we are not learning. Third one, of course third one doesn't have solution, so we are not going to create new solutions. That's why only we are covering models where we have formulas for them. Let's begin with them. First one is this one, basic model. T of n equal to, sometimes you get 2 into T of n by 2 plus n. I will explain you what is this model. In this model you have only one recurrence term. When you have only one recurrence term, then we can go for substitution technique. I will tell you what is substitution technique. So in the substitution technique, what we do is, first of all we write smaller recurrence terms. That means this is T of n, right? We try to write T of n by 2. So T of n by 2 is what? According to this one, 2 into T of n by 4 plus n by 2, isn't it? So this is, let's say, equation number 2. Similarly, we write T of n by 4. T of n by 4 is 2 into T of n by 8 plus n by 4, isn't it? This is equation 3. Let's try it one more time so you understand the pattern behind them. T of n by 8 equal to 2 into T of n by 16 plus n by 8. After that, what I do is I substitute these values back to the original equation. Let's take the first equation again, T of n. This is substitution time. T of n equal to 2 into T of n by 2 is equation number 2, 2 into T of n by 4 plus n by 2 plus this one, n, right? Now let's expand it. This will become 2 square into T of n by 4 plus 2 into n by 2, n plus n, right? Now we'll try to eliminate T of n by 4 this time using equation number 3. That is a technique. So that will become T of n equal to 2 square into, let's replace T of n by 4 with equation number 3. Then what happens? It will become 2 into T of n by 8 plus n by 8, n by 4 plus remaining thing is what? N plus n, right? So we'll see that what happens. 2 square into 2, 2 cube into T of n by 8 plus 2 square, 4 into n by 4, n plus n plus n. So slowly you can realize that every time we are getting one n, correct? Now this will become 2 cube into T of n by 8 plus n plus n plus n. Now we have not substituted 4. Let's do that. 2 cube into T of n by 8 is what? 2 into T of n by 16, right? Plus what? N by 8 plus remaining thing. What is the remaining thing? N plus n plus n. So this would become 2 power 4 into T of n by 16 plus 8 into n by 8 is n plus n plus n plus n. Every time one n is added to the result, correct? And this recurrence term is reduced. Initially we had T of n, after the T of n by 2, n by 4, n by 8. In that way, slowly this term is going to be reduced, correct? Now we'll try to make it such a way that it is which is smallest. And one more thing, whenever you have recurrence relation, base term will be given like this. Let's say T of 1 equal to 1. That is also given, otherwise we can't solve it. So what I do is, somehow first I write general term. If this is 2 power 4 into T of n by 16 plus n plus n plus n so on, next time what I can do is, I can substitute T of n by 16 value. What is that? 2 into T of n by 32 plus n by 16. So in that way you can continue and I can come to some general term. That means if I continue this process, what happens is I get T 2 power I. See, observe, 2 square, 2 cube, 2 power 4. So after some time, 2 power I, you will get T of n by 16 is nothing but 2 power 4. It will become 2 power I here. So this is called ith term, okay? So after I iterations I can say. 2 power I into n by 2 power I plus how many n's you will get? After 4 times you are getting 4 n's. See here, after 3 times you are getting 3 n's. After 1 time you are getting only 1 n. So after I times you get how many n's? N into I, correct? Now, but this I is our variable. What I represents? Pass number. That means this is pass number 1, this is pass number 2, you see. This is pass number 3 here. This is pass number 4. After ith pass, this is the equation. Then if I equal to, what I do is I carefully plan I value. Sir, what you plan? I will tell you. So that this recurrence term should be cancelled. We know T of 1 is 1. Then I know only T of something for 1. Correct? Then my goal is getting 1 here. For that n by 2 power I should be dash 1. Then n should be equal to what? 2 power I. Then what should be I for that combination? Log n base 2. So I realize that whenever I equal to log n base 2, then n by 2 power I is 1. Let's substitute it. It will become 2 to the power of I is what at that time? N by 2 power I is 1. Then 2 power I equal to n. Correct? N into T of n by 2 power I is what? That is what our goal. Making it 1. T of 1 plus n into I. What is I? Log n base 2 at that time. So that will become n. T of 1 is 1. N into 1 plus n log n base 2. So this is a solution. In that way we can solve the recurrence relations when you have only one recurrence term, like T of n equal to 2 into T of n by 2. Otherwise T of n equal to T of n minus 1 plus something. Otherwise T of n equal to anything, like only one recurrence term. T of n equal to some 8 into T of n by 20, anything plus something, anything. But only one recurrence term. Then always go for substitution. Okay, and you get solution, but it takes lot of time, but if you practice it, then quickly you can answer. Okay, now what we do is we are going to cover some more recurrence relations. Sometimes what happens, you will have multiple recurrence terms. Example, T of n equal to T of n minus 1 plus T of n minus 2. If you use substitution technique, it will be very difficult to answer. That's why whenever you have multiple recurrence terms, then how to answer it? Substitution method won't work. Then fortunately we have formulas. Okay, so I am going to cover some of the recurrence relations for which we have formulas. Okay, we'll see that. So recurrence relations can be classified into three parts. One is linear homogeneous, linear non-homogeneous, and non-linear. So non-linear recurrence relations are very difficult to understand. They don't have solutions. So that's why we don't bother about this non-linear recurrence relations. If you get non-linear recurrence relation, then it is very difficult to find out the value of it. So in the GATE exam they never give non-linear recurrence relations to it. So don't worry about them. So only they give linear homogeneous, linear non-homogeneous, because only they have fixed formulas to solve them. So let's begin with linear homogeneous. Okay, and one more thing. So in linear homogeneous and linear non-homogeneous, so the coefficients we are talking about them. So the coefficients should be constant. I will tell you what is coefficient here. So coefficient should be constants here and here. Here also same thing. Okay. Example of linear homogeneous recurrence relation I will tell you with constant coefficients. Only they have formulas to calculate the value. Example of linear recurrence relation is like this: an equal to something like an minus 1 plus an minus 2. This is an example of linear recurrence relation. So how to check, sir, whether it is linear or not? Simple. When you have a recurrence term, nth term, so that nth term is written with some sum of previous terms, like some previous term, another previous term. If you write a term, nth term, with respect to sum of previous terms, then that is called linear recurrence relation. Sir, what is non-linear recurrence relation? This one, you see, an equal to something like 2 into an minus 1 plus an minus 2 whole square. You see here, this is not linear recurrence relation. Here you have an minus 2 whole square. That means an minus 2 whole square is nothing but an minus 2 into an minus 2. So it is not sum of previous terms. Here this is not previous term. So it is previous term power 2. Correct? So that is not linear. If you have only one an minus 2, then we say it is linear. Example, an equal to 2an minus 1 plus 3an minus 2 is one example of recurrent relation with linear. Okay, so we have seen what is linear and non-linear. Now we'll see what is homogeneous and non-homogeneous. In linear recurrence relation, you can have linear, homogeneous, non-homogeneous. We'll see one by one. Example, an equal to an minus 1 plus an minus 2 plus some n square. Okay, second one, an equal to an minus 1 plus an minus 2 plus 2. Third one, an equal to 5 into an minus 1 plus, let's say, 6 into an minus 3 plus 2 to the power of n. Fourth one, an equal to an minus 1 plus 5 into an minus 2. Now I am going to tell you what is homogeneous and what is non-homogeneous. So when you have linear recurrence relation, and if you see this term, it is not recurrence term, right? If you have some recurrence terms followed by some function f of n, then that is called non-homogeneous. If there is no function, only you have recurrence terms, that is called homogeneous. So this is a linear recurrence relation, already we know that, which is homogeneous. Here these three are having functions, right? That's why I can say that these are all non-homogeneous. Now we'll see the structure of any linear homogeneous equation. It will be like this: an equal to some like constant, otherwise value like f of n. Okay, so I can say constant 1 into an minus 1 plus some constant 2 into an minus 2 plus constant 3 into a of n minus 3 plus so on some ck into an minus k. This is linear homogeneous recurrent relation with constant coefficients. Here this is called coefficient. Okay, now one more example, you see, an equal to n into an minus 1 plus n square into an minus 2. This is, see, an minus 1, an minus 2. We don't have powers to an minus 1, power to an minus 2, correct? Just power of 1, power of 1. Then that is linear. So this is linear. Second one, homogeneous, because there is no f of n, right? So it is homogeneous but with non-constant coefficients. Here coefficients are not constant. Okay, so sir, if we have variables like n and n square as coefficients, do we have formulas? We don't have formulas. Even we don't discuss them. So we are going to discuss only two things. One is linear homogeneous with constant coefficients. Second one, linear non-homogeneous with constant coefficients. For them we have solutions, we have specific formulas. Okay, for remaining things we don't have solutions. That means, so we can't directly, always we can't find out the solution with some particular formula. So we need to play some tricks. Sometimes even tricks won't work. That's why we don't discuss them. Only we discuss two things: linear homogeneous, linear non-homogeneous, especially with constant coefficients. Okay, we'll see that. Now we'll see linear homogeneous recurrence relations with constant coefficients of order k. Then what is order k? When you have a recurrent relation with k terms like an minus 1, an minus 2 up to an minus k, then we say that is order k recurrence relation. So, and one more thing, ck should be non-zero. So why? If ck is 0, what happens? 0 into this will become what? 0. Then this term will not appear. That's why definitely ck should be non-zero. Then only it will be order k. Understand? Next. So where c1, c2, c3, ck are real numbers and they are constants. Already I told you, because we are discussing linear homogeneous recurrent relation with constant coefficients now, and especially order k. So whenever you have such recurrent relation, these base cases are important. That means these recurrence terms are important. What are they? a0, a1 up to ak minus 1. So I will tell you with example. Whenever you have a recurrence relation like an equal to an minus 1 plus an minus 2, then to answer, that means to find out the value of an, you need two base cases. They are a0 and a1, otherwise a1, a2. Okay, so that's why at least two base cases are important in this recurrence relation also. So since there are k terms, there should be k base cases and you should know them. Then only we can uniquely find out the solution for an. So our target is finding solution for an, right? For that you should have these k base cases. Example, Let's say you have recurrent relation like this, an equal to 2 into an minus 1 plus 3 into an minus 2. Then we'll see whether it matches with our definition or not. It is linear, yes. Homogeneous, yes, because there is no function after this recurrence terms. Then constant coefficients, correct. And base cases should be given. Let's say a naught equal to 1, let's say a2 equal to 3. Then definitely we have solution for it. Okay, so what is solution then, sir? I will tell you. For that, first of all, step number 1 is you should find out characteristic equation. Okay, so characteristic equation will be in this form: r power k minus some c1 into c1 is nothing but that in that equation c1 into r power k minus 1 minus c2 into r power k minus 2 minus c3 into r power k minus 3 so on minus c naught. This is called characteristic equation. Whenever you have recurrent relation, first of all you have to find out characteristic equation, and this method only works for linear homogeneous recurrence relations with constant coefficients. Okay, example, let's say an equal to an minus 1 plus an minus 2 is the example. This is linear recurrence and homogeneous and constant coefficients. So we have to find out the characteristic equation. Let's do that. First of all, we have to find out k. And what is r, sir? So where r is called characteristic variable, otherwise it's simple variable, we have to find out that r value. So we are going to find out roots for this characteristic equation. So first of all, we try to we try to draw a characteristic equation for this an equal to an minus 1 plus an minus 2. Ready? So here first observe what is k. So here k is nothing but 2, correct? Then equation will be r power k. K is 2, r square minus constant 1. So this is c1, this is c2. Then constant 1 is what? 1 into r power k minus 1, r power 1 minus an what is constant to 1 into r power k minus 2, 2 minus 2 0. So this will be the characteristic equation. So that is nothing but r square minus r minus 1. So we'll see what to do with this characteristic equation. Just remember that for every homogeneous linear recurrence relation, we have to find out this characteristic equation. We'll see one more example and we'll try to calculate characteristic equation. For that, step number 1 is we have to write characteristic equation. What is characteristic equation? I will tell you. So characteristic equation looks like this. There will be a variable r which is called characteristic variable. Okay, so r power k is nothing but order of this recurrence relation, r power k minus constant 1 into r power k minus 1 minus c2 into r power k minus 2 minus c3 into r power k minus 3 so on minus ck. This is the last term. So let's take one example and do it. An equal to, let's say, 5 into an minus 1 plus 6 into an minus 3. For this we try to write characteristic equation. So here k is nothing but this one, 3, correct? So order of this one is 3. So r is a variable, r power k is what? 3, r cube minus constant 1. This is constant number 1. Okay, what is constant number 2? Constant number 2 is not 0, correct? Why? Because c2 is associated with an minus 2. Since there is no an minus 2 here, I can say that we have 0 into an minus 2. That's why c2 is 0. Then c3 is 6. So let me write it. c1 5 into r power k minus 1, r square minus second one 0 into, so 0 into anything is 0. After that minus 6 into r power, this time k minus, this is k minus 1, this is k minus 3, right? K minus 3 is nothing but 0, r power 0, which is nothing but 1. So this is the characteristic equation for this problem. So we will see one more example. An equal to, let's say, 5 into an minus 1 plus 3 into an minus 2 plus, let's say, 4 into an minus 3 plus 2 into an minus 4. For that, what is characteristic equation? So we have all the terms, correct? Then this is c1, this is c2, this is c3, this is c4. So order is here 4. So r power k, r4 minus c1 constant 1, 5 into r cube minus 3 into r square minus 4 into r power 1 minus 2 is the characteristic equation. Yes, so you understand finally what is characteristic equation, correct? Once you get characteristic equation, we have to find the roots of that characteristic equation. So we'll see how to find out the roots of characteristic equation. So what is a characteristic equation and roots we'll see. So here order is 2, then will be r power k 2 minus c1. This is constant 1, this is constant 2. So 1 and 1, right? Minus r minus 1. So this is characteristic equation. I would like to find out the roots of this one. How to find out roots for any algebraic expression? We know that we equate it to 0, right? Then, so the direct formula for any polynomial of degree 2, for that we know the formula. So whenever any expression has degree 2, then the formula for it is minus b plus or minus b square minus 4ac by 2 into a. Remember it. So for that reference is this one. Whenever you have any expression like a r square plus b into r plus c, this is polynomial of order 2. For that roots are minus b plus or minus root under b square minus 4ac by 2a. So if you don't know this one, then easily we can find out the roots for it. So here we have a equal to 1, b equal to what? Minus 1, c equal to minus 1, then minus b. What is minus b? Minus of minus 1 plus or minus root under b square minus 1 whole square minus 4 into a, 1 into minus 1 by 2 into a, 2 into 1. So it will become 1 plus or minus root under 1 minus, so this will become plus 4 by 2 into 1 2. It will be 1 plus or minus root under 5 by 2. So there are two roots. One is 1 plus root 5 by 2. Second one 1 minus root 5 by 2. That's it. Okay. So we'll see one more example and we'll try to find out the characteristic equation followed by roots. So one more example. An equal to 6, an minus 1 minus 12, an minus 2 plus 8, an minus 3. I am writing characteristic equation. So we know that here order is 3, correct? So formula is r power k minus c1 into r power k minus 1 minus c2 into r power k minus 2 minus c3 into r power k minus 3, so on, correct? Minus ck. Let's try that. So here r power k. K is what? 3. R cube minus c1 6. So here c1 is 6, c2 is minus 12 and c3 is 8, correct? So 6 into r power k minus 1, r square minus of c2 minus 12 into r power k minus 2 1 minus c3 8 into r power 0, right? We have to stop at r power 0. Then this will become r cube minus 6r square plus 12r minus 8. So this is a characteristic equation and we'll try to find out the roots for it. So how to find out the roots for an expression with order 3? For that we have studied in our 7th standard or 8th standard that first of all we have to use trial and error and we have to find out one root. So let's try to substitute r value 1. If you substitute r value 1, what happens? You just observe, it will be 1 cube 1 minus 6 plus 12 minus 8. So 1 minus 6 minus 5 plus 12, 7, 7 minus 8 minus 1. So it is not satisfying. When I substitute r value 1, so this is not becoming 0, but I am just searching for r value where this equation will become 0. So let's try r value 2. We have to try everything. First of all, we have to start with r value 1, after that 2, 3, similarly minus 1, minus 2. So it is just trial and error. So let me try with 2. So when r equal to 2, 2 cube is what? 8 minus 2 square, 4 into 6, 24, 8 minus 24 plus 12 into 2, 24. So this will become 24 minus 8. Yes. If you see here, so this equation is satisfying r value 2, correct? So that's why I can say that this equation has a root r minus 2, remember. Of course, otherwise 2. So this equation has a root 2, so that r minus 2 will become factor. This 2 has significance. So whenever 2 is a root, then r minus 2 will become factor of this equation. So what about other factors? How to find out other factors is very simple now. So divide this equation with r minus 2. The technique is like this. So take the expression here r cube minus 6r square plus 12r minus 8 and divide it with r minus 2. First of all, r cube. So try to get r cube. For that we have to multiply r minus 2 with what? R square. If I multiply this with r square, then what I get, I get r cube. Let me multiply r into r square, r cube minus 2 into r square, 2r square. You get r cube minus 2r square. So always try to get this higher order term. Such a way we have to find out the quotient. Now if I do subtraction, what happens? R cube will get cancelled. Then minus 6r square plus 2r square minus 4r square plus, so just take the next term 12r. Now again target is what? We have to get minus 4r square. Such a way we should divide. So r into dash is minus 4r square minus 4r. That's why multiply with minus 4r. So now we'll see r into minus 4r. It will become minus 4r square, right? Minus 2 into minus 4r, it will be plus 8r. So if you do this one, this is called division process. You might have known it. Then subtraction. So when you do subtraction, this will be cancelled. You get 12r minus 8r, 4r, right? Now again you take minus 8 as row. So r minus 2 and 4r minus 8. What is this term? 4r. Try to get 4r. Such a way you multiply. So plus 4 if I multiply, you see r into 4, 4r. That's why we have to take here plus 4. It will be 4r, 4 into r, 4r minus 8, correct? Yes. Then total will be cancelled, correct? You get 0. Then this will be coefficient. That means this entire equation is nothing but r minus 2 into r square minus 4r plus 4, which is equal to 0. Then r equal to 2. Otherwise r square minus 4r plus 4 equal to 0. Then if you see this one, it is r minus 2 whole square equal to 0. Then again you get here r equal to 2. So because of this one, it is r equal to 2. Because of this one, again you got r minus 2 whole square equal to 0, then r equal to 2. Then this equation is supposed to have 3 roots, but all are same. You see, whenever you have a polynomial of order 3, you will get 3 roots. Here all roots are 2 comma 2 comma 2, all are identical. Understand? So otherwise here you can apply minus b plus or minus b square minus 4ac by 2a formula. Then you get 2 as answer. 2 2's you get. So finally this equation has 3 2's. So this is about identifying the characteristic roots. So one more equation, this one. Here order is 3. Then equation is r cube minus constant 1. This is c1. 1 into r power 2 minus constant 2, which is minus 1 into r power 1 minus constant here 1 minus 1 into r power 0, correct? So it will become r cube minus r square plus r minus 1, right? This is the equation. So we have to find out the roots for it. So r cube minus r square plus r minus 1 equal to 0. Then it is easy to see that if I substitute r equal to 1, what happens? It will be 1 minus 1 plus 1 minus 1, which is 0. Correct? That means this equation has one root, which is 1. We have to find out other roots. For that we have to divide this equation with r minus 1. Let's do it. Either you divide, otherwise we can use one trick. I will tell you that also. That is r cube minus r square plus r minus 1. Begin. First we should get r cube. For that coefficient is r square. If I multiply with r square, then r minus 1 into r square is r cube minus r square. Right? Then it will be minus plus. So cancelled. Then r minus 1 will come. We can take r minus 1. Then multiply it with what? Plus 1. Then it will become r minus 1. R minus 1 will be cancelled. Understand? So finally r minus 1 into r square plus 1 is nothing but this entire equation. So r minus 1 into r square plus 1 equal to 0. So for that roots are r is already 1. Second one, r square plus 1 equal to 0. Then r square equal to minus 1. R is plus or minus root under minus 1. So plus or minus root under minus 1 is nothing but I. Correct? Imaginary number. So finally we got 3 roots. One is 1. Right? Second one plus I minus I. So this is about roots of this one. We can do in alternative way. Rather than dividing, we can use this common technique. What is that? Take the common. R cube minus r square plus r minus 1. Let's take r square common. Then what happens? It will become r minus 1 plus 1 into r minus 1. Now take r minus 1 common. Then what happens? This will be r square plus 1. Correct? then this will become r minus 1 into r square plus 1. If you equate it to 0, you will get roots, and same roots you get, correct? So this is about finding the characteristic roots. Now it's time to find out the solution for linear homogeneous recurrence relation. So we have, let's say, linear homogeneous recurrence relation, and this is characteristic equation. First what you have to do is we have to find out the roots for this recurrence relation. Okay, then roots are, let's say, Ri, where I is ranging from 1 to t. Example, let's say there are t roots for it, R1, R2, so on up to Rt, and each root is repeating mi times. Sometimes what happens, roots might get repeated, correct? Example, your equation is r minus 3 whole cube. Then we say that for this kind of characteristic equation, so the root 3 is repeated how many times? 3 times. Okay. So sometimes what happens, root might not be repeated. So we say that at that time it is repeated one time. So yeah, so we have some roots and some repetitions. Then for such characteristic equation, the recurrence relation solution is this one. There are a lot of constants, alpha 1 0, alpha 1 1. So up to how many constants we should take, I will tell you. It depends on, see, m1. What is m1? The number of times a root is repeated. What is root? In characteristic equation we have roots, right? So based on that we are going to write this equation. So better we take one example so that we can understand it. Example, let's say your characteristic equation has roots r1, r2, r3. R1 is, let's say, 2, R2 is, let's say, 3, R3 is, let's say, 4. Okay, then R1 is repeated, let's say, 2 times, R3 is repeated, R2 is repeated 3 times, and R3 is repeated, let's say, 1 time, and these are all repetitions, let's say Mi. Okay, so here this is M1, this is M2, this is M3. Then first focus on root number 1. This is R1 power n actually in the formula. So see the equation. Alpha 1 0 plus alpha 1 1 into something plus alpha 1 2 into something. Sir, how long we should go like this? Up to 1 m1 minus 1. What is m1 here? Number of repetitions 2, correct? 2 minus 1. 2 minus 1 is 1. That means alpha 1 1. So we should write this equation starting at alpha 1 0 and up to alpha 1 1. Let me write it. Alpha 1 0 plus alpha 1 1 into n. Stop it because we have to write only up to 1 1 into that root power n. What is root here? 2. Then 2 to the, sorry, this one, 2 power n plus. Now we have to write same kind of expression for R2. That's it. How many times it is repeated? 3 times. Then so that will be, the expression will be like this. Second one is, what is the formula for second one? It will be like this: alpha 2 0 plus alpha 2 1 into n plus alpha 2 2 into n square, so on, plus alpha 2 comma m2 minus 1, I mean into n to the power of m2 minus 1 into root power m. So what is root here? Root is r2 power n. So here again, sir, how many constants we should take? It's again depends on repetition. So second root is repeated 3 times. Let's substitute m2 value 3. Then this will become 3 minus 1, which is 2. Then alpha 2 2 into n power 2, correct? That means we have to go up to alpha 2 to n square. So let me write it. That means alpha 2 0 plus alpha 2 1 into n plus alpha 2 2 into n square into r2 power n. What is second root here? 3 power n. That's it. Similarly, third one. What is third one? Third one, for third one equation will be like this: alpha 3 third root, alpha 3 0 plus alpha 3 1 into n plus alpha 3 2 into n square, so on. Ending point is what? Alpha 3 comma root repetition. What is that repetition? m3 minus 1 into n power m3 minus 1 into that root power, let's say r3 power n. Correct? So let's do that again. What is m3 here? Let's substitute 1. 1 minus 1 0. That means we should go to only alpha 3 0 n power 0. That means first term. So these all terms will not be there, correct? So it will be alpha 3 0 into, so I can say alpha 3 0 into directly this r3 power n. So what is r3 here? 4 power n. That's it. Okay, so here it is 2 power n, it is 3 power n, it is 4 power n. Just observe. So if for 2 power n, since repetition is 2 times, we got 2 terms. For 3, it is repeated 3 times, that's why 3 terms. 4 is repeated only one time, you get 1 term. So this is the solution for your recurrence relation whose characteristic equation has roots 2, 3, 4 and their repetitions are 2, 3, 1. So finally it's very clear for you. Whenever you have a recurrence relation, first of all calculate characteristic equation and identify the roots. Once you identify the roots, you will come to this point. Then once you get the roots, then you know how to write the equation. That will be the final solution for this problem. That's it. Example an equal to minus an minus 1 plus 4 an minus 2 plus 4 an minus 3 with some values a0 and a1 and a2. We know that when you have a0 and a1 and a2, which are 3 constants, then only we can uniquely find out the solution for it. So since there are 3 variables, understand there should be 3 initial values. So how to find out the solution for this one? First we have to identify characteristic equation. So what is characteristic equation for this one? R power, right? What is order 3? That's why it will be r cube minus c1. So let me identify c1. c1 equal to minus 1, c2 equal to 4 and c3 equal to 4, right? So r cube minus c1 minus 1 into r power n minus 1 r square minus c2 which is 4 into r to the power of 1 minus c3 which is 4 into r to the power of 0, which is nothing but we have to equate it to 0, correct? So let's do that. R cube minus into minus plus r square minus 4r plus 1 minus 4 equal to 0. We have to equate it. Now we have to find out the roots for this expression. If you see carefully, so we have 1, 1, minus 4, correct? So if I keep negative number, probably what happens, you see, let me try minus 1. This is all trial and error. So let me try for minus 1. So whenever you have an equation with polynomial of order 3, then how to find out the root number 1, how to find out the first root? For that we have to substitute r value 1, r value 2, r value minus 1, r value minus 2. In that way we have to try all the smaller values, then something will work out. That is what I am doing. So what I do is I will try with minus 1 first. Then what happens, it will be minus 1 whole cube plus minus 1 whole square minus 4 into minus 1 minus 4. Let's try it. Minus 1 whole cube minus 1 plus minus 1 whole square plus 1 minus 4 into minus 1 plus 4 minus 4. Yes, it worked. Then for this problem, what is the factor? R plus 1. Otherwise minus 1 is the root. Either minus 1 is the root, otherwise r plus 1 is the factor. So once you get one factor, what we do to identify the other factors, we have to divide this r cube plus r square minus 4r minus 4 with r plus 1. Okay, first step, try to get r cube, such a way you divide. For that, multiply r plus 1 into dash so that you get first term as r cube r square. That's why it will become r plus 1 into r square is r cube plus r square. Then if you do subtraction, they will be cancelled. Then next terms we have to take. One is minus 4r, then minus 4. Do the same. R into dash is minus 4r. So multiply with minus 4. It will be minus 4 into r. I am multiplying minus 4 with r plus 1. Minus 4r minus 4. Then this time this will be cancelled. Right? So when you get remainder 0, then this will become, factor. So r plus 1 into r square minus 4 equal to 0. Then one root is r plus 1 is 0, then r equal to minus 1. Second one, r square minus 4 is 0, then r square is 4, then r equal to plus or minus 2. Finally we got 3 roots. What are they? One is minus 1, second one plus 2, third one minus 2, any order. Let's say this is r1, this is r2, this is r3, and r1 is repeated only one time, right? R2 is repeated one time and r3 is repeated one time. So we have to write that expression 3 times, right? So let me write that expression one by one. First, r1 is minus 1, r2 is 2, r3 is minus 2, correct? Let me do it one by one. So the equation is like this: alpha 1 0 plus alpha 1 1, so on. How many times? Exactly, if you see the expression, so we have to go to number of repetitions times, number of repetition times. That means since minus 1 is repeated one time, we should write this expression one time, alpha 1 0. If this is repeated two times, then you will have alpha 1 0 plus alpha 1 1 into n. If this equation is, if root is repeated 4 times, then we will have 4 points. What are they? One is alpha 1 0, second one alpha 1 0 into n, third one alpha 1 0 into n square, fourth one is, alpha 1 0, alpha 1 1, alpha 1 2 and alpha 1 3 n cube. So 4 times we have to write. Since we have minus 1 only one time, then only one variable you get, one that is alpha 1 0 into root power n. What is root here? Minus 1 whole power n. So that is the meaning of this expression, plus. So let's write for this one. Same expression we write, but the variable name is alpha 2 0. So alpha 1 0, here alpha 2 0 into root power n, 2 to the power of n. Since third root also repeated only one time, only one variable you get, that is alpha 3 0 into minus 2 whole power n according to the formula. Then final answer is alpha 1 0 into minus 1 whole power n plus alpha 2 0 into 2 power n plus alpha 3 0 into minus 2 whole power n. Sir, what is alpha 1 0? What is alpha 2 0? What is alpha 3 0? These three are constants. We have to find them. How to find them? Using these hints. We have three base terms, right? A0, A1, A2. Let's use them. Since A0 is 8, then this is actually solution, correct? An. Let's substitute A0. That means n value 0. According to substitution, when you substitute n value 0, then A0 will become alpha 1 0 into minus 1 whole power 0 plus alpha 2 0 into 2 to the power of 0 plus alpha 3 0 into minus 2 whole power 0. Then that would become alpha 1 0 minus 1 whole power 0, 2 power 0, minus 2 whole power 0, everything is 1. Then you get alpha 1 0 plus alpha 2 0 plus alpha 3 0, which is nothing but A0. But A0 is 8. So remember that this is 8, equation number 1. Now let's substitute n value 1. Then what happens? A1 would be alpha 1 0 into minus 1 whole power n, where n is 1, minus 1 whole power 1 plus alpha 2 0 into 2 power 1 plus alpha 3 0 into minus 2 whole power n, n is 1. Then if you simplify, what is A1? 6, known value, equal to alpha 1 0 into minus 1 whole power 1, which is minus 1, alpha 1 0 plus alpha 2 0 into 2 power 1, 2 into alpha 2 0. Here minus 2 whole power 1 is minus 2, minus 2 into alpha 3 0. So this is second equation. Understand? Now what is third equation? If I substitute n value 2, let's do it. Then A2 equal to alpha 1 0 into minus 1 whole power, this time 2, correct? Plus alpha 2 0 into 2 to the power of 2 plus alpha 3 0 into minus 2 whole power 2. If I simplify it, you would get alpha 1 0 into minus 1 whole square 1 and 2 square 4 minus 2 whole square 4. Then you would get A2 equal to alpha 1 0 plus alpha 2 0 into 4, which is 4 into alpha 2 0 plus 4 into alpha 3 0. But A2 is nothing but 26, right? So these are the three expressions. You know one thing, when you have three expressions and three unknown variables, then if you simplify them, we can solve them uniquely. How to solve them, we'll see. Now let me equate them. There are three equations, 1 to 3. Alpha 1 0, what I do is first I take this 1 and 2 and I try to eliminate one variable. So it is easy for me to eliminate alpha 1 0. Then let's do subtraction. If I do 1 minus 2, what happens is these two will be cancelled. Then let me do 2 minus 1, it would be better. So anything you can do, of course. So let me write it first. Alpha 1 0 plus 2 alpha 2 0 plus minus 2 alpha 3 0 equal to 6. Second one, alpha 1 0 plus alpha 2 0 plus alpha 3 0 equal to 8. Okay. So let me do subtraction. When I do subtraction, 2 alpha minus 1 alpha is 1 alpha, alpha 2 0, minus 2 minus 1, minus 3 alpha 3 0 equal to 6 minus 8 minus 2. So this is equation number 4, remember it. Similarly, let me try to get one more equation with 2 0 3 0. Okay. So I use 2 and 3 and I try to eliminate alpha 1 0 one more time. Let's do subtraction. If I do subtraction, what happens? 2 minus 4 minus 2 alpha 2 0 minus 2 minus 4 minus 6 alpha 3 0 equal to 6 minus 26 minus 20. This is equation number 5. So now in 4 and 5 we have alpha 2 0 alpha 3 0 alpha 2 0 alpha 3 0. Then using 4 and 5, let's eliminate alpha 2 0. See, here you have alpha 2 0, you have minus 2 alpha 2 0. Let me multiply this with 2. Then what happens? 2 into alpha 2 0 minus 6 into alpha 3 0 equal to minus 4. Let's say this is equation number 6. Let's take this one, equation number 5, minus 2 alpha 2 0 minus 6 alpha 3 0 equal to minus 20. Okay. So either you can subtract, otherwise you can add, so that one variable will be eliminated. Let's do addition. So what happens if I do addition? This will be cancelled. You get 12 into alpha 3 0 equal to 20 minus 4, 16. So alpha 3 0 equal to 16 by 12, which is nothing but, if I simplify, 4 4 is 16, 4 3 is 12. You get 4 by 3. So I got alpha 3 0. Using that I can find out alpha 2 0 by substituting alpha 3 0 in this equation. Let me use equation number 4. So I am using equation number 2, equation number 4, alpha 2 0 minus 3 into alpha 3 0. What is alpha 3 0? 4 by 3 equal to minus 2. Then if I simplify, you get alpha 2 0 minus 3 3 will be cancelled, minus 4 equal to minus 2. Then alpha 2 0 equal to 4 minus 2, which is 2. So I got 2, right? So alpha 1 0 we have to find out. So alpha 1 0 equal to, you see here, alpha 1 0 equal to 8 minus alpha 2 0 and minus alpha 3 0. What is alpha 2 0? 2 minus, what is alpha 3 0? 4 by 3. If I do, you get 6 minus 4 by 3, which is nothing but 18 minus 3 6 is 18, 18 minus 4 14 by 3. So finally we got one more value, alpha 1 0. So answers are like alpha 1 0 is 14 by 3 and alpha 2 0 is 2 and alpha 3 0 is 4 by 3. Once you get these values, simply substitute them in your original equation. What was the equation? Did you remember? Let me write it one more time. So now final answer is, so we know that roots are minus 1, 2, minus 2. Then expression is alpha 1 0. Did you remember? Alpha 1 0 into root 1 power n. What is root power 1? Minus 1 whole power n plus alpha 2 0 into second root 2 power n plus alpha 3 0 into minus 2 whole power n, where alpha 1 0 is 14 by 3. Then it will become 14 by 3 into minus 1 whole power n plus alpha 2 0, 2 into 2 power n plus alpha 3 0 is nothing but 4 by 3 into minus 2 whole power n. This would be the solution. Understand? So you, of course you can simplify it here if you want, 2 power n and minus 2 whole power n. But here minus 2 whole power n depends on the parity of this number depends on this n value. That's why better don't simplify, leave it as it is. So this is about solution of recurrence relation, which is linear and homogeneous. We'll see one more example of linear homogeneous equation. So the equation is an equal to 6 an minus 1 minus 9 an minus 2, which is linear homogeneous equation with initial terms a0 and a1, which is 1 and 6. We have to find out the solution for this one. First we'll begin with characteristic equation. So characteristic equation is r power k. K is what? 2. R square minus c1. C1 is 6, c2 is minus 9. So c1 is 6 into r power 1 minus second one minus 9 into r power 0, right? So if you equate it to 0, what happens? It will be r square minus 6 into r minus into minus plus 9, r power 0 is 1 equal to 0. Then if I simplify it, see, r square minus 6r plus 9 is nothing but r minus 3 whole square, right, equal to 0. Then there is only one root, which is nothing but 3. But it is repeated 2 times. Whenever it is repeated 2 times, then for that root, let's say we have root number 1, then what would be the expression? I will tell you. First we start with, let's say this is root number 1, alpha 1 0 first term plus there will be one more term because it is repeated 2 times. That's it. Second one is alpha 1 1 into n. Sir, what if this 3 is repeated 3 times? You get alpha 1 0 plus alpha 1 0, alpha 1 1 into n plus alpha 1 2 into n square. So that is the difference. Now you get two terms because the multiplicity of this root is 2. That means 2 times it is repeated into n to the power of root power. What is root here? 3 power n. That's it. This is a solution. Sir, is there anything else? No, because in the previous problem we were having three roots. That's why we got this kind of expression 3 times. That's it. If you know how to write it, then you can write for every root. In that way, for every root we have to write this kind of equation. If you have second root, we would start with alpha 2 0. If you have that root also repeated 2 times, then you get alpha 2 0 plus alpha 2 1 into n in that way. If that is repeated 3 times, you get 3 terms, so on. Here there is only one root, then only one expression you get, and we have two variables, we have to identify them. Okay. So how to identify the alpha 1 0 and alpha 1 1? That's for that we use base. Okay. So first start with, this is solution, right? Finally I want to say that this is the solution for your recurrence relation. So that is alpha 1 0 plus alpha 1 1 into n into 3 to the power of n. Let's substitute n value 0 because we know a naught value. Using that we can find out alpha 1 0 and alpha 1 1. So alpha 1 0 is variable plus alpha 1 1 into n is what? 0 whole brace into 3 power 0. If I simplify it, so this would become 0, then a naught equal to alpha 1 0 into 3 power 0 1. Then directly we got a naught equal to alpha 1 0. So alpha 1 0 is a naught is 1. So we got alpha 1 0. Similarly, we can find out alpha 1 1 by substituting n value 1. Let's substitute. So here I am substituting n value 1. Then a1 would be alpha 1 0 plus alpha 1 1 into n 1 into 3 power n. N is 1. So it would be a1 equal to what? 6. 6 equal to alpha 1 0 plus alpha 1 1 into 1 into 3. Right. So if I simplify it, 3 1s are 3 2s are. Then you get alpha 1 0 plus alpha 1 1 as 2. But alpha 1 0 is 1. Then alpha 1 1 must be 1. So that's why I got alpha 1 1 as 1. So finally we got alpha 1 0 value, alpha 1 1 value. Let's substitute them. They will be 1 plus alpha 1 1. 1 into n. See, 1 plus 1 n into 3 power n. Okay. So it would be 1 plus n into 3 to the power of n. Okay. One more problem we'll see. an equal to 7 an minus 1 minus 18 an minus 2 plus 20 an minus 3 minus 8 an minus 4. So C1, C2, C3, C4 are 7 minus 18, 20 minus 8. Okay. Then what is the characteristic equation for that? R to the power of k. What is k? 4, right? So R power 4 minus C1 7 into R to the power of 3 minus C2 which is minus 18 into R to the power of 2 minus 20 into R to the power of 1 minus 8 into R to the power of 0. If you simplify it, you get R to the power of 4 minus 7 R cube minus plus 18 into R square minus 20 R plus 8, which is equal to 0. If you equate it, you get roots, right? So we'll see what are the roots for this one. So first of all, we should start with trial and error. Substitute R value something which is known for you, otherwise so try to guess something so that this would become 0. If you don't have any guess, then simply try R value 1. If it won't work out, try minus 1. After that 2, after that minus 2. We should go systematically. There is no other way. Let's do that. If I take R value 1, it would be 1 power 4 minus 7 plus 18 minus 20 plus 8. Correct? So if you see minus 20 plus 8 minus 12. So 1 minus 7 minus 6 plus 18. 18 minus 6 12. 12 minus 12 0. Yes. So R equal to 1 is one of the root. That means what is the factor of this equation? R minus 1. So what about the remaining equation? So R minus 1 into dash. To find out this dash, what we have to do is we have to divide this with what? R minus 1. We know that. R power 4 minus 7 R cube plus 18 R square minus 20 R plus 8. Take R minus 1 here. Let's start dividing. First step, R power 4 is our target. To cancel it, so we need R cube. Blindly write R cube and write the multiplication of R minus 1 into R cube here. It will be R power 4 minus r cube, right? If you do subtraction, this will be cancelled. That is what our intention. Then this will become plus minus 7 plus 1 minus 6 r cube. Now take one more term, 18 r square. Our target is cancelling r cube. For that, what is the coefficient? Minus 6. Multiply with minus 6 into r square. So that minus 6 r square into r is minus 6 r cube. Understand? So it will be minus 6 r cube. So minus 1 into minus plus 1 into 6 r square, 6 r square. You get like this. Then it will be cancelled. So we have to subtract, right? Then this will be 18 minus 6, 12 r square. Again take the next term, which is minus 20 r. Then target is divide, cancelling 12 r square. For that, multiply with 12. It will be 12 r. Then will be 12 r square minus 12 r into minus 1 minus 12 r. It would be cancelled and it would be minus 12 minus 20 plus 12 minus 8 r. So let's take plus 8. So r minus 1 into dash is minus 8 r plus 8. So again target is minus 8, correct? Minus 8. So r into dash is minus 8 r minus 8. Then it would be minus r 8 r plus 8, correct? If I multiply r minus 1 into minus 8. So this would be cancelled, this would be cancelled. Then yes, I got remainder 0. That means this is one more factor of this equation. So final answer is r minus 1 into r cube minus 6 r square plus 12 r minus 8. Again we should try finding the roots for this equation. Okay, so let me target it. R cube minus 6 r square plus 12 r minus 8. Let's try r value 1 again. I guess there is 1 is again root. If it is really good root, then it would be 1 minus 6 plus 12 minus 8 should be 0, correct? So 1 minus 6 minus 5 plus 12 minus 8 4 minus 5 plus 4. Is it 0? No. Then 1 is not root. So let's try minus 1. Minus 1 whole cube minus 1 minus 6 into minus 1 whole square is plus 1. 6 into 1 6 plus 12 into minus 1 minus 12 minus 8. So again it is not 0. Then I'll try next number, which is 2. Let's try 2 cube minus 6 into 2 square 4 plus 12 into 2 minus 8. 6 4 is 24, 12 2 is 24, gets cancelled, and 2 cube 8 minus 8, which is 0. Yes, we got one more root, that is r minus 2, otherwise 2. 2 is the root, otherwise r minus 2 is a factor. So r minus 1 into r minus 2 into dash. To know this dash, again we have to divide r cube minus 6 r square plus 12 r minus 8 with what? R minus 2. Let's do here. So we know that r minus 2 is a factor. To find out the one more factor, we shall have to divide r cube minus 6 r square plus 12 r minus 8 with r minus 2. Let's do it. First our target r cube. How to get r cube with r? Into r square. That's why we multiply, we multiply r minus 2 into r square. It would become r cube minus 2 into r square. So if I cancel them, you get minus 6 plus 2 minus 4 r square. Then take this one, 12 r. Then again same thing, r into minus 4 r is minus 4 r square. That's why multiply with minus 4 r, it would become minus 4 r square. Automatically r minus 2 into, we are doing like r minus 2 into minus 4 r. It would become minus 4 r square plus 8 r, correct? Then this will be cancelled. If I subtract, you get 4 r. Then take this one, 4 r minus 8, right? This one also. Then r minus 2 into dash is 4 r plus 4, correct? Then it would be 4 r minus 8. Yes. So finally it is completely cancelled. That means whenever you get remainder 0, that means this r square minus 4r plus 4 will become one of the factor to this one. So finally r minus 2 into r square minus 4r plus 4, if you multiply them, you get it back. That is what factorization of polynomials into dash. Previous one was what? R minus 1, correct? Finally you got r minus 1 into r minus 2 into r square minus 4r plus 4 equal to 0. Then you see this one. So r square minus 4r plus 4 is nothing but actually r minus 2 whole square, correct? A minus b whole square is a square minus 2ab plus b square. So r minus 1 into r minus 2 into r minus 2 whole square. which is nothing but r minus 1 into r minus 2 whole cube. So here there are two roots, one is 1, second one 2, but 2 is repeated 3 times, isn't it? 1 is repeated only one time. For that, let me write first of all for 1. So what is the solution for 1? That means final equation is, we'll have two components, one component for 1, one component for 2. Let me write component for 1. So final solution is first component alpha 1 0, because this is repeated only one time, you get only alpha 1 0 into directly root 1 power n, done. So this component is for this one. What about this one? For that, so we have to write like this. So alpha 2 0, since it is a second root, 2 0 plus, don't stop, write 3 terms because it is repeated 3 times. Second term is alpha 2 1, but that should be multiplied with n. That is what the formula. Then third term is alpha 2 2, which should be multiplied with n square. This entire thing into root power n. What is root here? 2. 2 to the power of n. Finally, answer would be alpha 1 0 into 1 power n, which is nothing but 1, plus alpha 2 0 plus alpha 2 1 into n plus alpha 2 2 into n square whole brace into 2 to the power of n. Here we have to find out what is alpha 1 0, what is alpha 2 0, what is alpha 2 1, what is alpha 2 2. Okay, 4 things. So definitely, of course, I did not mention here. They will mention what are the base cases, like what is A0, what is A1, what is A2, what is A3. They will provide. So you have to take them, and we have to find out alpha 1 0, alpha 2 0, alpha 2 1, alpha 2 2. I will tell you how to find out. Let me fix A0, A1, A2, A3. Okay. So let's say constants are given like this. Initial term A0 is 0, A1 is 0, A2 equal to 1, A3 equal to 2. Then how to find out this alpha 1 0, alpha 2 0, alpha 2 1, alpha 2 2 is a question. Once you get it, then answer is this one. This is final solution. So by substituting n value 0, what happens? A0 equal to alpha 1 0 plus alpha 2 0 plus alpha 2 1 into n. N is 0 now. If I substitute n is 0, this will become 0, this will become 0. Then you don't get any other term into 2 power 0, right? N is 0. Then it would become alpha 1 0 plus alpha 2 0, which is nothing but A0, which is 0. So equation 1. Now substitute n value 1, you get one more equation, which is 2. After that 3, after that 4, by substituting n value 2, n value 3. Once you get 4 equations, we have to solve them. So given 4 expressions or 4 mathematical, otherwise algebraic expressions, how to simplify them, right? So but it takes a lot of time. Generally, even when we were studying our intermediate, otherwise in our 10th standard, when this kind of questions are given for 4 equations, we generally don't solve, because if and all if we solve also, we take at least 15 minutes of time to solve them. That's why this kind of question they don't ask in GATE. Understand? So at least you stop the solution at this moment, at this place. Don't calculate these constant values. What is alpha 1 0, what is alpha 2 0. Then at least if that is the case, we would save our time. And one more thing, in GATE exam, definitely they don't ask this much lengthy questions. Understand? So don't solve them. Okay.